In parts 1 through 5, we took a close look at a heartbeat, taking what's happening in your chest and connecting that to what you're seeing on the strip. But we used a perfect heartbeat for that lesson. If all heartbeats were perfect, we wouldn't need to interpret rhythms, so now we need to start breaking down the pieces of a rhythm so that we can efficiently identify anomalies on a strip to alert us to problems with conduction and ultimately with delivery of that life-sustaining blood that comes from every beat. As we work through the library of arrhythmias, we'll use a method of interpretation called the 8 Steps to Interpretation. It's a systematic approach to rhythm interpretation that will ensure you look at every important aspect of a strip and identify anomalies in an order that will help you to smoothly, efficiently, and accurately identify the rhythm. As stated before, we are talking about rhythm interpretation, looking at a single lead and identifying the rhythm, not looking at all leads and comparing them to identify specific areas of damage, infarct, etc. That's a different beast entirely. So for our purposes, we will be viewing primarily lead 2 and looking at these 8 specific areas. 1. Determine atrial and ventricular regularity. 2. Determine atrial and ventricular rate. 3. Evaluate the P wave. 4. Evaluate the PR interval. 5. Evaluate the QRS complex. 6. Evaluate the T wave. 7. Calculate the QT interval. And step 8, which is admittedly my least favorite step, is more of a catch-all for other things you've noticed. It's called Other Components, and I'll explain what that means when we get to step 8. The first thing you'll need to do is print 6 seconds of a strip. Like we said before, that's the gold standard for interpretation. Then we get into the steps. Step 1 is determining atrial and ventricular regularity. Well, what is regularity? In the heart rhythm world, regularity is the even spacing of a complex across a strip. So, if we are looking at atrial regularity, what complex do you think we need to focus on? The P wave is our atrial depolarization. So, are the P waves evenly spaced across the strip? Take out your calipers. Put one point at the beginning of a P wave. Put the other point on the beginning of the next P wave. You now have what is known as a P to P interval. If your rhythm is regular, that same P to P interval will match the spacing of every adjacent pair of P waves on your strip. Take your calipers and test the spacing of all the P waves on the strip. Now we need to know ventricular regularity. So, same idea, but this time we'll be looking at the ventricular depolarization, which is the QRS. And unlike the P wave, which is a nice little bump, the QRS has a convenient point at the top. So, that's what we'll use for our measurement. Put one caliper point on the top of a QRS. The top of the QRS is known as the R point. And then put the other caliper point on the top of the adjacent QRS. You now have what is known as an R to R interval. And you check regularity by taking your calipers and matching that spacing to all the QRS adjacent pairs on the strip. Simple, right? Now we need to get into the weeds a little bit. To be regular, the spacing of complexes doesn't need to be perfectly matched. There can be a variation of up to 0.12 seconds, or 3 small boxes, between the fastest interval and the slowest interval on a strip. And it is still considered regular. Variations that are this small are not concerning. But once the difference between the fastest and slowest intervals is greater than 0.12 seconds, it is worth labeling. And we call that irregular. So if every P to P or R to R interval on your strip is within 0.12 seconds difference or less, mark it as regular for the respective chambers. Anytime you find 2 P to P or R to R intervals on a strip that are greater than 0.12 seconds different, mark that as irregular for step 1. And then, move on to step 2, calculating atrial and ventricular rate.